Okay, part two. So I can drag this out of the way. Um, so let's talk about solving this equation. Actually, this equation way up here. If you were doing it by calculator approximation, now you might wonder why we need to do this because you're already adept at doing this with a quadratic formula. But we want to be able to use the calculator to solve equations like, for instance, this one down here, a cubic. It would really take a long time or maybe be impossible with our algebraic tools. So let's look at it in this simpler case where we've got alternatives. We've got this graph of a parabola, and this is basically y equals x squared plus 2x minus 5. And then looking at this graph, ask yourself, well, where is x squared plus 2x minus 5 equals 0? In other words, where is y equal to 0? What values of x would make y equals 0 and therefore solve that equation? And we see two different places. Basically, the x-intercepts are values of x where the second coordinate is 0. So if we can locate those intercepts, otherwise known as the zeros of the function, that's where the output y will be 0 and where that equation will have its solutions. So on the calculator, I'm going to, let's see, make this bigger. I'm going to turn it on and look at my y list again. Look at my y equals list. And I have that, that parabola entered right up here, right? And if you need to enter that yourself, which you will, use the variable key here that's got x, t, theta on it. That's where you enter the x. And then just use, subtraction, addition, the squaring key, and other stuff on the keyboard to enter that equation. Notice that I've got the equal sign highlighted right here. That means it'll show on the graph. I've got this other equation in here but no highlight, so that won't show on the graph. And I can change the highlighting by just moving the cursor over the equal sign and hitting enter. It toggles it on or off. Okay. So now I'm looking at my graph. Let's see, I think if I press this, is that it? No, I'm on the wrong side here. Press graph. I will have this graph up here, and I want to locate the zeros. And I'm going to use a function on the second calc menu to do that. So I'm going to press second, and let's see, calc is the second function of the trace key up here, and you get this menu that you'll use a lot in this homework this week. Value, 0, minimum, maximum, intersect. 0 is what we'll use to find where those x-intercepts are, where the graph crosses the x-axis. So I can either use my arrow key to come down here and highlight 0 and then hit enter, or, there we are, hit enter. Or I could press number 2, just press 2 and it would give me that second function. Okay, so here I've got that, sorry if the focus is a little bad, I've got that parabola graphed, and I chose second calc 0 to find the 0, and the calculator prompts me, it says, what left bound? Well, I want to locate a certain 0. I'm going to locate this one where the graph crosses the x-axis here. And so I'm going to move my cursor using the arrow key. Let's see, here are the arrow keys over here. And if I press this one, wrong way, press this one. See how the cursor is moving along the graph? I want to move it to the left of the 0 I'm looking for. So for instance there, that would be to the left. And if I hit enter, it's going to put in a little arrow. See the little arrow way up here? It says that's kind of my left bound. Then it prompts me and says, what's the right bound? So I'm going to move to the right, and see how the cursor moves to the right. And then when I hit enter, it's going to give me a, see the two arrows up there? It's going to give me a left and right bound. And what the calculator is doing is it's saying, I'll find a 0 in between those two arrows. Then it says guess, and you could move the cursor closer to the 0, but for most cases, if you just hit enter, that'll work. It's going to find the 0 when I do that. moves the cursor to the 0, and it gives me a very accurate estimate of where the 0 is. Let's see, can you see that? It says x equals negative 2.449 and y equals 0. Negative 3.449, right? And actually, if I round that, negative 3.449, I'm going to get negative 3.45, exactly what we got by following the quadratic formula. So this is an alternate way of locating. By locating that 0, I'm locating a solution. And you will need to locate the other, there's one of my solutions. You need to find the other one by repeating those steps. With that graph showing in your calculator, hit second calc 0, second, and then the calc button, and then select number 2 or arrow down to 0. It'll ask you for a left bound and a right bound, and you move the cursor and hit enter to set the left bound and right bound, then hit enter one more time to find that 0. Something else you can do when they ask for left and right bounds, if you put in 0 for the left bound, like it says left bound, you just press 0, it would set the arrow at 0. So you can do it by just entering a number as well as by moving the cursor. Most of the time people just move the cursor. Okay, now let's do something very similar to find the vertex of the parabola. This is something you probably remember how to do from Math 95. You could use the formula opposite of b over 2a in order to find the first coordinate of the vertex, and I think it comes out quite nice, as you can see my answer here. But let's do it with the second calc menu. So here I would hit second calc, and I would select minimum to find a local minimum of the graph. Now minimum is function number 3, so I'm just going to press my fingers on 3. I'm just going to press 3, and it'll take me to the minimum function. And once again, it's going to ask left bound, right bound. So it looks like that minimum, you know, when you just look at the graph, the vertex, the minimal, local minimum is, I don't know, close to -1. If I just hit -2, enter, and then for right bound, hit +1, enter, it'll set my arrows there. See the left and right arrow on the screen, and it'll find a minimum between those two. It says guess. I'll just hit enter, and it should move the cursor right to the minimum, and it should give me a might be a little bit easier to see here. It should give me fairly accurate accounting of what the coordinates of that point are. So it says that occurs at -0.999986, and where y is equal to -6. Well, if you round that to the nearest hundredth or nearest thousandth or 10,000th or 100,000ths, it'll round to exactly 1, -1, and I believe that's actually the case. So I just entered -1, -6 here. You see how that would be exactly accurate if you round to the nearest hundredth or thousandth. Okay, so let me go down to the last item here, which is a more challenging item, and it says you can't tell from the graph of this weird cubic how many solutions this equation has. Well, let me see what that means. If I go to the y equals list again, but I have that equation entered in there for speed, but I'm going to turn off the parabola, and I'm going to move my cursor over to the equal sign on the other graph and hit enter, so that now that one's highlighted. And then if I go and press graph to go to my graph on a standard viewing window, this is going to draw the picture for me. This complicated cubic looks like this. Okay, now I could sketch that graph on this window, this standard viewing window, but it's a little bit hard for me to see what's going on there at the local minimum. I see the graph as I scan from left to right. I see that the graph, where's the finger? Okay, let's see. I see that it increases as I go from left to right up to a local maximum here, and then it starts to decrease down to this local minimum before it starts to increase again. And if you look at that local minimum, the bottom of the valley over there, it's hard to tell what's going on at the axis. Does it touch the axis? Does it not touch the axis? Does it touch the axis in two places where it crosses the axis and comes up? My screen resolution is just not sufficient in order to see that. So here's what I'm going to do. I'm going to do some zooming in to get a better picture of the graph. And I'm going to use the zoom menu for that. So I'm going to press zoom and I get all of these choices. Zoom in, zoom out, those will just zoom in toward the cursor or away from the cursor. Zoom decimal, zoom square is a square window. Z standard gives you the standard -10 to +10. Let's use the first option, Z box, which is a really nice one. I'll hit enter. It'll take me to the graph, and the cursor starts at the origin. And I'm just going to move the cursor using my arrow keys. See my little cursor there? And I'll hit enter. And then I'm going to move the cursor to the left and up until I get a little box like this. And this is saying I want to investigate what's happening in that little teeny weeny box. Let's see. So if I hit enter now, it's going to give me a new graph that just investigates what's happening right there. Boy, this is hard to see. It looks like the graph might not actually even get down to the bottom, or might not get down to the axis. Let me use zoom box one more time and look super close. I can really make this microscopic, you know. So I pick that box and I see that actually that local minimum is all above the x-axis, interestingly enough. So let me zoom back to my original. I'm going to go zoom 6, which is zoom standard, and it'll take me back to that original viewing window. So what I see here is that the equation where I set this cubic equal to 0 is going to only have one solution. It's going to have a solution right here, where there's a 0, where it crosses the x-axis. It sort of appears in this window like there could be solutions over here, but I'm not going to be able to find those because the graph doesn't actually touch the x-axis. There's only one solution. Now here's another point about this. When you draw this graph, it says zoom using zoom in or using Z box, as I did, to get this picture. When you get this picture, you want to sketch like we had this little loop that doesn't quite hit the axis. You want to have the axis and the loop in there. But you also want to enter these values. And this is pretty important to tell somebody what you're looking at. So after you do that zooming, go to the window. I'm going to press window here, but this isn't what you'll see after the zoom because this is the standard viewing window. And look at X min and X max. Those values should be filled in here, just like they are up here with -10 and 10. So you can tell somebody, oh, we're just looking from x equals 0.9 to x equals 1.2 or something like that. And also enter the minimum and maximum y values from that window screen. And that basically is a quick way of saying, this is what I saw, and this is what my window, this is what the boundaries of my windows were. Finally, it says list approximate solutions to this equation. Well, you're going to find that approximate solution using second calc 0, but because of your investigation of the graph, this zoom in, you're going to know to look for only one of those. It's interesting what happens when people try to find other zeros where they don't exist. Of course, the calculator kind of frustrates that effort. Okay, have fun filling in the rest of this, and I'll see you with a short video for the next page.